Okay, equations. That is in this something like this: x squared plus 4x minus 5 equal to 0. And we learned different way to solve the quadratic equations. And last week, we learned about rational equations. And basically, to solve rational equation, we just make them into either a linear equation or quadratic equation. So one of the things we learned, for example, we got say 3x plus 5 equals to 4x plus 1. So what we did is we're going to multiply the denominators. So that way we turn that into a linear equation. So we do that, multiply the same on both sides. And that cancels. We got 3x plus 1. And this cancel, we got 4x plus 5. So now you can see we got 3x plus 3 equals to 4x plus 20. Then that's a linear equation. So minus 3x. Then we got x plus 20 equal to 3, going minus 20 on both sides. Then x equals negative 17. And once we got that, like when we solve any equations, we actually need to check. So that's called the verification. So 3, negative 17 plus 5, that gave us 3 over negative 12, and that is 1/4. So that's on the left side. We want to see the right side. Do they equal? 17 plus 1, so 4 over negative 16, which is negative 1/4. So therefore, this is the real answer. Good.
Did you do when you subtracted 3 from both sides, shouldn't you have subtracted 4 from the one side?
It doesn't matter which one you go. I like to keep mine positive, so I just took a negative 3x on both sides.
Oh, okay, so it doesn't matter?
No, doesn't matter.
Okay.
It's just like well, make sure we want to get rid of x from either side. We can either get from left-hand side or we can get rid of from right-hand side. Good.
Yep.
Yeah, if we do on the right-hand side, then we'll get negative x. I mean, you can still do it. Just like personally, I like dealing with positive. Good.
Yep.
Okay, so now we actually learn something called the radical equation. Now, well, first of all, before we learn the radical equations, we learn something called radical expression. Radical expression is something like this, say 3x, and it's inside the variable is inside the square root. Or we could square root of x plus 5. And we could even have something like this, x squared plus 3x minus 1. That's all called radical expression. Good.
Yep.
And one of the things about the radical is we got a couple rules. One rule is if we got radicals like that, then we can combine them, put them all both inside. So rule 1. And rule 2 is if you have something like this, that's the same as we do this. Good.
Yep.
And so a couple examples to do that. Let's say if we got square root 7 times square root 5, we can write as square root 7 times 5, which is square root 35. Or if we do square root 8 divided by square root 2, then we can put them together as this. and that gave us square root 4. We got 2. Good.
Yep.
Okay. So let's just try a couple. One is square root 2 times square root 8 and see what you got.
Is it square root 16?
Yeah, which is
4?
yeah, square 16. That's 4. Very good. And if we have, say, square root 27 divided by square root 3.
It equals 3.
Yep, very good. So that gave us 27 over 3, square root 9, then we got 3. Very good. Good job. So now we got looking at the radical equations. So radical equations, some could be pretty easy. For example, 3x equals to 6. Then we just square root on square on both sides. That's how we can open up the 3x. So we got this, then the 36. That's a linear equation divided by 3. So then x is 12. And we can check 3 times 12, that's square root 36. That is indeed 6. Good.
Not exactly. Could you explain it one more time, please?
Well, first of all, we got this. And we need to get x out of the radical sign. So the way we do that is just square on both sides. Are we good here?
Yep.
So square root 3x squared, that is 3x. And 6 squared, 36. And now this is just a linear equation. So we just solve as a linear equation, we divide by 3 on both sides. Then x is 12. Good?
How is 3 square rooted only 3 and then 2 square or 6 square rooted 36?
Well, 6 squared means 6 times 6, right?
Yep.
What is square root the square of square root 33x? That is 3x times 3x, right?
Wouldn't that be 9 though?
No, because we have a square root, we got there is square root for it. You can think this as 9x squared, but basically what we got is 3x.
Okay.
Okay.
Yep.
Well, for example, what's square root 2 times square root 2?
4.
No, that's actually 2. Because this is square root 4. Square root 4 is 2.
Oh, okay.
And say this times that.
Would it be 3?
Yeah. So whatever inside the square, the radicals, when you take square, you basically free this from the radical. Good.
Okay.
So anything like say x squared, it just equal to x.
Okay.
Make sense?
Yep, that makes sense.
Okay. So now we're gonna look in something maybe just a little bit more. So 2x minus 4 equal to 7. How do we do that? We want to free the 2x from the radical. So we just add 4 on both sides, so can isolate in this term. Then we got 2x on the left, right side is 11. Then we square it on both sides. Then we got 2x on this side, other side is 121. Then x will be 121 divided by 2. Get?
Yep.
All right, now let's looking at another equation. I just want to kind of maybe put it together like this. Is x plus 1 equals square root of 2x minus 5. So in this case, we square on both sides. What we got here is x plus 1 on the left. So we do the square root on both sides. On the right-hand side is 2x minus 5. Well, that's just a linear equation. And I'm going to rewrite this as 2x minus 5 equals to x plus 1. So minus x on both sides. We got x minus 5 equal to 1. We add 5 on both sides. Then x is 6. Good?
You subtracted x from the x plus 1 to the.
Yeah.
Okay.
Because I don't, what you need to do is just get rid of x from one side. I mean, you only have x on just one side of the equation. Good?
Yep.
Okay, so I'll let you try a couple problems. First one is this. 3x minus 5 equals to 3.
I'm not sure what I did wrong.
Okay, what's your first step?
Do you need to add 5 to both sides first, or do you square root both the sides first?
You have to add it first because then we can isolate the radical.
Okay, and I did that right.
Okay, so add 5 on both sides. And this side is 3x. Then we got 8, right?
Yep.
So now we need to free 3x from the radical. So we just square them on both sides. Then we got 3x on this side. Other side just 64. Okay?
Yep.
and we divide by 3 on both sides. So x is 64 over 3. Good.
And that's, you don't, okay, so I did everything right apparently, but I tried to divide 64 divided by 3 and I got like 21.333 or whatever.
Right. I mean, you don't have
So
to. You can just keep as a fraction.
okay, that makes sense.
Mhm. Okay. Let's try 2x minus 5 equal to -3. And that's what you got.
X equals 2.
Very good. So add 5 on both sides. Then that give us 2. Then square, opening that up. So 2x equals 4. Then divide by 2. Very good. Okay. So now let's do this. 3x plus 1 equal to the number 2x plus 3.
Does X also equal 2?
So we got square on both sides, right?
Yep.
So we got 3x plus 1 equal to 2x plus 3, right?
Yep.
Minus x on both sides. That's
Yep.
x on both sides. So x plus 1 equals 3 minus 1. Very good. So x is 2. Yep. Good job. Okay, let's do another one. Minus 5 equals to 3.
Does X equal 66?
Yep, very good. You can see that 66 minus 2 is 64, which is 8. And 8 minus 5 is indeed 3. Good job. Okay, now we're going to get, so far, we see that we change a radical equation into a linear equation. Okay. Now, sometimes we actually have to change it to a quadratic equation. For example, if we got something like, say, 2x plus 3 minus 5 equal to x. So what we do on here? Well, we add 5 on both sides. Then we got 2x plus 3 equals to x plus 5. And then we square on both sides. And now on this side, easy, 2x plus 3. But on the other side, what we got here become x squared plus 10x plus 25. Yep, are we good here?
Yep.
Okay, so now we're going to, now we have this quadratic term. So this is a quadratic equation. And to do that, we have to make that into this form, ax squared plus bx plus c equal to 0. Okay, so basically we write this as x squared plus 10x plus 25 equals to 2x plus 3. So we have minus 2x minus 3. Then we got x squared plus 8x plus 22. Good. Make that inside. So we got 8 squared plus 8x plus 22 equal to 0. Good.
Yep.
Well, now what we see here is we can just use the quadratic formula. We got minus 8x minus 8 plus minus a squared minus 4 4ac 1 and 22. And we got 2 here. Now we got negative 8 plus minus 64 minus 88. Now here we have a problem. 64 minus 88, that is negative 24, which means we don't, the solution is a complex number, and which means that we don't have a solution. We call the real number solution. Good. So that means no matter how hard we try, there is no a real x value that meet this condition. Good. Let me try to let's see, to graph that. Okay. Let me 2x plus 3 minus 5. Okay. I'll just show you this. Now, can you see it?
Yep.
So what we are doing here, because we are we're trying to solve 2x plus 3 minus 5 equal to x. which is basically two functions. This function and this function, we'll see if they were equal. When they are equal, that means they are intercept each other. And you can see that they are not, there's no intersection between this function and this function. Good?
Yep.
Okay. All right. So now we're going to see a different, another example. Oh, wrong one. X plus 1 plus 3 equals x minus 5, and see what happens. Okay, we'll got square root of x plus 1. We minus 3 on both sides. Then we got x minus 8 squared. Oh, sorry, minus 8. Then we square on both sides. What we got here is x plus 1 on the left. On the right, then x squared minus 16x. Well, actually, let's see something different.
Why wouldn't 8 be 64?
Oh, not there yet. This is this one. X minus 8 squared is x squared minus 16x plus 64. Good. I just haven't write it out yet.
Oh, okay.
Let me try to find a good example for this. Okay, x minus plus 9 plus 2 equals x plus 3. Okay, let's do that one. And we got x plus 9 equals to x plus 1. Good? Yeah, are we okay here?
Yep.
Then we square on both sides. What we got here is this side is x plus 9. The other side is x squared plus 2x plus 1. So we rewrite it as x squared plus 2x plus 1 equal x minus 9. Then we minus x on both sides. Then we got x squared plus x plus 1 equal to negative, plus 9 equal to 9. Then minus 9 on both sides. Then we got x squared plus x minus 8 equal to 0. Good? Yeah, are we?
Yep.
Okay, so now you can see we changed the radical equation into a quadratic equation. Then we just solve as that. We can, so we know our A is 1, B is 1, our C is negative 8. So our X then will be minus B plus minus B squared minus 4AC over 2A. And that we got minus 1 plus minus 1 squared is just 1 minus 4. A is 1, C is negative 8 over 2. So now we got negative 1 plus minus 1 plus 32 over 2. So we got minus 1 plus minus 33 over 2. And that's our answer. Good?
What is this the answer for?
No, just for this equation. this equation. Good?
Oh, okay, so once you got it down to
Yeah.
x plus or x squared plus x minus a equals 0, that's not your final answer?
No, this is we just change it to the quadratic equation. So we change the rational equation into quadratic equation. Then we still have to find x. So it's continue to solving it.
Okay. And
Good.
then that is the first part just your formula?
Well, the first part is to convert the radical equation into a quadratic equation.
Well, yeah, I understand that, but then down at the second one is the x minus b plus minus b squared minus 4. Is that your
That's a,
formula?
that's a quadratic formula, right?
Okay.
Do you
And so
remember that?
yeah, I remember that, but then the next part, is that where your problem actually starts?
Well, the next part will basically we just plug in the number, right? Our A is 1, B is 1, C is -8, right?
Yeah.
Then that help us to find what X is.
Okay.
Good?
Um,
You're not quite sure.
I think so. Yep.
Okay. All right. Let's uh try another one. 4 uh, uh, plus 3 equals to X plus 2. Okay. We minus 3. Then we got, so the first thing is isolate the radical. We did that. That's X minus 1, right?
Yep.
Then we square on both sides. So we can free up the X plus 4. So it's X plus 4 equals to X squared minus 2X plus 1, right?
Yep.
And so we rewrite like this. So this is called symmetrical property of equality. And that allow us to change that minus X minus 4 minus X minus 4. So what we got here is X squared minus 3X minus 3 equal to 0. Good? Yeah, are we good?
Not quite. Let me write it down real quick.
Mm-hmm.
Yep.
Okay. All right. So now we're going to solve that. We got A equal 1, B is -3, C is -3. So we just use the formula. So we got X is minus -3 plus minus -3 squared minus 4A and -3. And bottom is 2 times 1. So we got 3 plus minus 9 plus 12, right? Okay.
Yep.
And over 2. So we got 3 plus minus square 13 over 2. Good?
Yep.
Okay. So let's just give a try, okay? Okay, let's see what you got.
So can you work the problem out just to where I get to find out what A, B, and C equal, just so I know I've done it correctly so far?
Okay, what's your first step?
Add 1 to both sides.
Mm-hmm. Then we got x plus 9 equal to x plus 3, right?
Yep,
Then open them up. X plus 9 is equals to x plus 3 squared, right?
yep.
And that is x squared plus 6x plus 9, right?
That's not what I got.
So what's your got for x plus 3 squared?
I got x squared minus 6x plus 1.
X squared minus 6 and x plus 1.
Yeah, no, just plus 1.
Okay, how do you get there?
Well, and I'm not exactly sure because with your other example, I didn't understand how you got from that part. I didn't understand how you got from x plus 3 squared to,
This part.
yeah, how you added another. I didn't understand that part.
Well, what is x plus 3 squared? It's just x plus 3 times x plus 3, right?
Okay.
Right? That's what x squared means, right?
Yep.
Well, how do you FOIL this? You got x times x squared, right?
Yep.
X times 3, that's 3x, right?
Yep.
And then this times that, that's 3x. And this times that, give us 9. Good.
Yep.
So that's where the 6x come from.
Oh, okay.
Cross that. Okay.
Yep. I got the 6x part. I just didn't get the plus 9
Okay. And do you know why? Why you didn't get 9?
because I didn't take the 3 times the 3.
Okay. All right. So we have here, right?
Yep.
Now we can rewrite this as x squared plus 6x plus 9 equal to x plus 9. And now we got x squared minus x is plus 5x plus 9 equal to 9, then minus 9. Then we got x squared plus 5x equal to 0, right?
Yep.
That means our A is 1, B is 5, our C is 0, right?
Yep.
Okay, so our x then will be minus b plus minus b squared minus 4ac over 2a, and that gave us negative 5 plus minus negative 5 squared. Since c is 0, we basically is minus 0, right?
Yep.
And 2 here, and that gave us negative 5 plus minus square root of 25 and over 2, and that give us negative 5 plus minus 5 over 2. So we either got negative 5, we got two answers, negative 5 plus 5 equal to 0, that's 0, good?
Yep.
And the other one is negative 5 minus 5 over 2 for negative 5, good?
Yep. And can you just walk through again how you subtract, or is it negative 5 minus 5 and then whatever that answer is divided by 2?
Yep.
Okay.
5 minus 5, that's negative 10, right?
Yep.
Divided by 2 and negative 5. Okay.
Yep.
Well, now we have to go back and check the answer, okay? I kind of missed that early on, but we have to checking it because when we change this radical equation to our quadratic equation, we might introduce we call this so-called bogus solutions. So let's see. we got, say, x equal to 0, x is -5. Plug in negative 0, we got square root 9 minus 3 equals to 0 plus 2. Sorry, it's a 1. And square root 9 is 3. 3 minus 1, that is 2. So that is good. Both sides are the same. And we can also plug in -5 in there, and you can see we are getting a problem here. -1. The other side will be -5 plus 2, which give us -3. But on this side is 4 minus 1, which is 2 minus 1 is 2. And 2 definitely not equal -3. So therefore, this solution is a bogus solution, not a valid solution. Okay.
Yep.
So that's what you do when we doing the change that radical equation into quadratic equation, that we could introduce a bogus solution. Similarly, like rational equation, change rational equation to quadratic equation, we will have the same, facing the same issue. So we have to verify, we have to check. Good.
Yep. And it makes sense. It was just that I didn't understand where you got that one equation part from.
Okay. Yeah, this actually something we learned is this: a plus b squared, called square of sum, that equals to a squared plus 2ab plus b squared. Okay.
Yep.
Yeah. So if you're not sure, you can always just work it out. Okay. And now you can see this is a square, and times that, ab, then times that, ba, which is same as ab, then lastly, this times that, b squared. So we got a squared plus 2ab plus b squared. Okay.
Yep.
And another way for us to kind of to see this is using we can using a rectangle, actually a square. This is a plus b. This is a plus b. Good.
Yep.
So now you can see that if we cut this, what we got here is this part is a square. Good.
Yep.
And this part is a b squared. And this is a times b, this is a times b. So therefore, a plus b squared is a squared plus, there's 1, 2ab plus b squared. Good.
Yep.
Does that make sense?
Yep. It does now.
All right, wonderful. Okay, I'll see you next week. Okay,
Okay. Thank you very much.
you're welcome. Bye.